What is a mole? Just the Facts is an episode of the Degrees of Freedom Project videos on chemical and thermal principles. Definitions and additional details can be found in the webpage link in the description. A mole is the name given to the mass equivalent of the molar mass of a molecule. For example, a molecule of carbon dioxide has a molar mass of 44.010. So a gram mole, or simply mole of carbon dioxide, has a mass of 44.010 grams. And 1 pound mole of carbon dioxide has a mass of 44.010 pounds mass. The NIST website lists 15 different mass units, so there are at least that many types of moles, ranging from the carat mole through the pennyweight mole. The most common ones are the gram mole, or mole, the kilogram mole, or kilomole, the metric ton mole, or ton mole, the pound mole, and the ton mole. A mole is most useful when planning out or preparing reagents for a chemical reaction. Start with a balanced chemical equation for the reaction. For example, 1 carbon atom and 1 oxygen molecule react to form 1 molecule of carbon dioxide. To make 100 pounds of carbon dioxide from the carbon and oxygen, calculate the needed carbon atoms and the needed mass of oxygen molecules. For an atomic species like carbon, the correct name is pound atom or gram atom, but the pound mole or gram mole is acceptable when it won't cause confusion. The chemical equation states that 1 pound atom of carbon will react with 1 pound mole of oxygen molecules, or 2 pound atoms of oxygen atoms, to form 1 pound mole of carbon dioxide. Given that the molar mass or molecular weight of carbon dioxide is 44.009546, which rounds to 44.010, 100 divided by 44.010, or 2.272 pound moles of carbon dioxide. We need 2.272 pound atoms of carbon and 2.272 pound moles of oxygen molecules. The atomic mass of carbon is 12.010736, which rounds to 12.011, and the molar mass of O2 is 31.998810, which rounds to 31.999. So, we need 2.272 times 12.11, or 27.29 pounds of carbon, and 2.272 times 31.999, or 72.70 pounds of oxygen. Incidentally, if you want to wait until the end to round for your calculations, you'll get 100 pounds instead of 99.99 pounds of CO2. A mole without a mass qualifier is assumed to be a gram mole. The U.S. Standards Agency, the National Institute of Standards and Technology, or NIST, specifies on their website that there are exactly 6.0221476 times 10 to the 23rd molecules in a mole. That number is known as Avogadro's number, or the Avogadro constant. However, there's a corresponding number for each mass unit. For pounds mass, the exact number is 1.327,654,687,33603 times 10 to the 27th per pound mole, which is calculated using the conversion from grams to pounds mass on the NIST website of 453.5924 grams per pounds mass. It is possible but unwise to use the gram mole in all of your calculations. With it, you're more likely to make an error from the extra conversions. The calculation process for a mass unit other than the gram is as follows. 1. Convert mass unit to grams. 2. Convert from grams to gram moles with the molar mass. 3. Use the chemical equation to find the resultant gram moles. 4. Convert from gram moles to grams, then finally, 5. Convert from grams to your original mass unit. Don't do this. With the original mass unit moles, the steps are 1. Convert from mass to moles with the molar mass. 2. Use the chemical equation to find the resultant moles. And 3. Convert from moles to mass. 3 steps instead of 5 for the gram mole results in 40% fewer places to make a mistake. The summary is 1. Engineers use different types of moles because they have to work with different types of mass units. 2. The molar mass is just the conversion factor between moles and mass, and has the same numerical value regardless of the mass units involved. And 3. Only use gram moles if the problem specifies grams. Otherwise, use the mole corresponding to the mass unit. Thanks for watching! This video was brought to you by the DOFPro team.